All right, today we're going to dive into the story of one of the most influential programming languages ever. Seriously, it was born from this one single philosophical question that completely changed computer science as we know it. This is the story of Lisp.
So let's start with a really wild thought. What if the code you write wasn't some special secret language, with all its own rigid rules and syntax? What if it looked exactly the same as the data you were working with? This one idea, it's called homoiconicity, fancy word I know, but it is the key to understanding Lisp. It literally means that code can build other code. Back then, that was a revolutionary idea, and trust me, it's still incredibly powerful today.
Okay, so to really get why this was such a huge deal, we've got to rewind. Let's go all the way back to the early days of a brand new, super ambitious field. We're talking about the quest for thinking machines. So picture this. It's the 1950s. The pioneers of computing are getting a little bored with just building, glorified calculators. They started asking much bigger questions. They were like, can we build a machine that can actually reason, that can solve problems, maybe even think? And this new frontier, this crazy new challenge, got a name: artificial intelligence. And right away, they hit a massive wall. See, the languages they had, stuff like Fortran and COBOL, were absolute beasts at crunching numbers. Perfect for science, great for business. But AI? Well, AI wasn't about numbers. It was about symbols. Think about it for a second. How would you even begin to tell a computer about a concept like love or a relationship like is the father of? You can't do that with just numbers. The tools they had were completely wrong for the job. So there was this giant flashing question mark. What kind of language could even do this? And this is where our hero enters the scene. A brilliant computer scientist over at MIT, a guy named John McCarthy. And he had a really big idea. McCarthy's team basically realized that for AI to work, you had to tear down the wall separating code from data. The breakthrough was thinking, hey, what if we could write a function, a piece of code, using the exact same format we use for data? That was it. That was the philosophical leap that kicked everything off. And the structure they came up with was so simple. It was just the list. All a list is a bunch of stuff inside parentheses. That's it. The stuff inside can be what they called atoms. Think single letters, numbers, whatever. But here's the magic trick. The stuff inside can also be other lists. So you can just keep nesting them, like you see here, building these really complex tree-like structures out of one ridiculously simple rule. So armed with this super simple idea, the list, McCarthy's team went on to build a whole new kind of language. Let's see how it works. Okay, check this out. This is what data looks like in Lisp. Just a list of words: apples, oranges, grapes, wrapped in parentheses. Simple enough, right? It's just a collection of stuff. Now look at this. This is Lisp code. It's telling the computer to add 10 and 5. Yeah, the plus signs at the front. That's just called prefix notation. But look closer. Forget what it does for a second and just look at how it's written. It's just a list, isn't it? A symbol, then two numbers, all inside parentheses. So, wait a minute. We had a list of fruit, and now we have a command to do math. But syntactically, look at them. What's the difference? Is there any difference in how they're structured? And here it is, the big punchline. In Lisp, there isn't one. There is no difference. Code is data. Data is code. They're the same thing. They're both just lists. And this is what makes Lisp so unbelievably powerful. It means a Lisp program can build new pieces of Lisp code just as easily as it builds a shopping list. A program can look at its own code, change it, and create new functions while it's running. This is the whole idea behind metaprogramming, programs that write programs. It's wild stuff. Okay, so this whole code is data thing led to what is honestly one of the most mind-blowing discoveries in the history of programming. It led to something called the universal eval function. So the team had this startling realization. Since code is just a list, they thought, wait, couldn't we just write a function that takes a list, any list that represents code, and just runs it? And they did. They called it eval. Think of eval as the ultimate Lisp program. You can feed it any piece of Lisp code and it will execute it. And here's the crazy part. If you have a function that can run any other Lisp function, that means you can write a Lisp interpreter in Lisp. The snake eats its own tail. It was this beautiful, profound moment where they proved the language was totally self-contained. So how does this magic actually work? It's way simpler than you might think. Eval just grabs a list, it looks at the very first thing in the list and goes, okay, that's the function I need to run. Then it just applies that function to everything else in the list. So for plus 2, 3, it sees the plus, applies it to the 2 and 3, and boom, you get 5. And it's smart enough to handle nested lists too. If you give it something like plus 2, multiply 3, 4, it'll dive into the inner list first, solve multiply 3, 4 to get 12, and then solve the outer one, plus 2, 12 to get 14. It's just this elegant little loop. Read, evaluate, print. Simple, but so powerful.
You see, Lisp was never just a programming language. It was really a collection of game-changing ideas. And like all really good ideas, they didn't just stay put. They spread, they evolved, and they are still a huge influence on how we all write code today.
As time went on, the Lisp family kind of split into two main flavors. First, you've got Scheme. Think of it as the minimalist, elegant Lisp. It has a tiny, beautiful core, and it's fantastic for teaching computer science concepts. Then you have Common Lisp. This is the everything but the kitchen sink version. It's massive, packed with features, and built for creating huge industrial strength applications. Two different philosophies, both born from the same core ideas.
And here's the main takeaway for you. Even if you never, ever write a single line of Lisp in your life, its DNA is all over the languages you use every day. Python, JavaScript, Ruby, you name it. The idea of using recursion as a go-to tool, that's pure Lisp. Treating functions like any other variable, passing them around, that comes from Lisp. Dynamic typing, where you don't have to worry about declaring variable types all the time. Yep, Lisp was a pioneer there too. All of these things we just take for granted now, so many of them trace their roots right back to Lisp.
And that really brings us full circle, back to that core idea. Lisp's real legacy isn't just the code. It's the question it makes us ask. If a program can literally rewrite itself while it's running, if the line between the programmer and the program starts to get blurry, then what are the limits? What can we actually create? I mean, can a program be truly intelligent if it can't understand and change its own source code? It's a huge question that developers are still grappling with. And it all started from that one simple, elegant, world-changing idea: what if code was just data?